Hi there, welcome to your first calculus video. Throughout these notes, I will record notes. Feel free to pause the video or fast forward if you really understand something. Go back and rewatch it as needed. So we're going to start our first unit. It's going to focus first on limits and then go into continuity. And what's special about limits as far as calculus is that it really distinguishes itself from algebra and trigonometry. It's really kind of a unique topic. First in this course, we're going to look at defining. We're going to define what a limit is. We're going to do that in a lot of different ways. I'm going to give you a chance to really understand what a limit is. We're going to learn how to calculate limits. And now, basically, in order to calculate limits, we can do them graphically. Okay, and I really want you to have good intuition graphically on how to calculate a limit. We can do a numerical approximation with a table and use a calculator to find a table. We could do a table by hand as well. We're going to look at them approximately. We're going to use some algebraic methods. We're going to do a combination of these. We might do a combination of graphing and algebra, combination of these. And we're also going to use what's called the sandwich theorem. Okay, so that's in general what we're going to be looking at in this section. There's top four different sections, and each section in calculus I usually find takes about 2 days. Okay, so now we're going to get into the difference between two types of speed. First, we're going to look at what's called average speed. Okay, and I'm going to go forward onto the next page just to show you where we're going to go. And then after we do average speed, we're going to look at what's called instantaneous speed. Instantaneous speed is where calculus really comes in and limits really come into the situation. So let's first look at average speed. Okay, average speed, we're basically going to calculate that as your distance traveled divided by your time elapsed. If you want to, you could look at that as your change in your y over your change in your t. Okay, so let's look at this example here. Here's our example. We have an object is dropped from rest at the top of a tall building. And it falls at the function y equals 16 t squared feet in t seconds. Okay, and the question for us is find the average speed during the first 3 seconds. Okay, so to calculate that, I'm just going to use this formula over here. I'm going to look at my change in my y over the change in the t. So I'm looking at change in y over change in t. And we're looking at this function, 16t squared. Okay, so change in y, distance is going to be your 16 over your initial time, or the final time is at 3 squared, minus, so it's from 0 to 3. So over that. Okay. And then that's going to give me the change in the t. Change in time is the difference in time. So that's going to be 3 minus 0. Okay, so that's going to end up giving me, what, 16 times 9 over here and 3 in the denominator. So that ends up being 48 feet per second. Okay, so your average speed in this case is 48 feet per second. Do pay attention to your units. You do want to make sure you get the units correct on your problem. Okay, so average speed's nothing real new. Instantaneous speed is where calculus starts to come in handy. Now, we start to have difficulty calculating instantaneous speed. Basically, calculus was invented to solve this type of problem because what we're going to do when we get here, we're going to do the same example as we just did. But instead of calculating average speed, I want to know what the speed is at 3 seconds. Okay, and we're going to still use that same formula of y equals 16t squared. Okay, so if I use the average speed formula, and if you're thinking average speed formula is not going to work, you've got some good intuition there. So I'm just going to do this in red because it's going to be wrong, but I just want to show you why it's wrong. So if I do my delta y over delta t, that's going to give me 16 over 3 squared minus, now I want it at 3 seconds, so I would just end up with 16 over 3 squared. I'm not doing anything here. And then I would do 3 minus 3. So that's going to result in 0 over 0, and that's undefined. So the speed at 3 seconds, though, is not undefined. I should be able to calculate what it is. So what we do is we kind of use this trick, and it's a beautiful trick. And the trick is to calculate the average speed by using 2 different values for t. We're going to use a value of 3, and then we're going to use a value of 3 plus h. Now, we all know that h is 0, but we're going to pretend that h is not 0, and we're going to just let it be 3 plus h. And now we're going to be able to calculate the instantaneous speed. Okay, so to go ahead and do that now, I'm going to calculate what the instantaneous speed exactly is going to be. Okay, so I'm going to go back to my delta y over delta t. And in this case, I'm going to take 16 over 3 plus h squared minus 16 over 3 squared all over 3 plus h, okay, minus 3. Okay, so let's clean this up a little bit. You can see that the denominator, the 3's, would cancel here. And then I would be left with 16 over 9 plus 6h plus h squared minus 16 over times 9 all over h. Okay, now I could multiply this out, but I'm just going to show you what's going to happen here. So I've got 16 times 9 plus 16 times 6h plus h squared. You could multiply it out, but I'm just going to show you what's going to, this will happen with all the problems that you do. Is basically what happens when you do this, and you'll know you're on the right track if this happens. This first term and this term are going to cancel each other out. Okay, so now I'm left with 16, oops, I switch colors here. 16 times 6h plus h squared, okay, all over h. Okay, so now we keep going here, and I can factor out an h out of the top. So I'm going to be left with 90, what do I got? 96h plus h squared over h. So now I'm going to be left with factoring out an h. So I've got 96 plus h all over h, and the h's cancel. So I'm left with 96 plus h. And now we go back to our original problem, and that at the very beginning, h was 0. So our instantaneous rate is 96. Okay, so this will work on every problem that we do, because these first terms will cancel out here, and then you will be able to go through and cancel out. Okay, I'm not getting right exactly into how this connects to limits, but we will do that in the next couple videos.